For number 29, it says two neighboring cities are growing at the exact same rate. The first city, however, has a smaller population than the second city. The graph illustrates the population's growth of the first city, modeled by the equation f of x is equal to 150 parentheses 1.04 end parentheses to the power of x. So they give you the graph for the first city, and we notice that it starts at population in the thousands, 150,000, and as it slowly increases over time. If the second city's initial population was twice as great as the first city's initial population, which graph represents the population growth at the second city? So the initial population was 150,000, so we would want to look for a graph that starts at 300,000. So A clearly starts in the beginning for 300,000. B does not, and instead it increasingly goes up at the beginning of 150. D, although it does start at 300,000, it rises way too rapidly than it should, because the rate is only doubling. It's not increasing almost tenfold as this one seems to be. And then this population only begins at 250,000 and doesn't begin at 300,000. So the only obvious answer that could be correct would be A. Even for another example, whether if it was 200 or 250, 300,000, it wouldn't matter. So long as the first city, this would still be its initial population. And for the second city, since it doubles, you would want to double the amount that begins for the equation. And then for however many times it is increasing right here, for this it's 1.04. Let's say it was 2. So, and then to the power of x. The rate should increase almost double as well. So for this, you can see clearly at 150,000, it steadily goes up, and it reaches a peak here with 200,000 over the course of about 5, 6, 7 to 8 years. And so you would want to find a rate that instead cuts this in half, and it would drop it instead to 4. It would reach that in 4 years.